This slide introduces the concept of async await in JavaScript, which is a modern approach to asynchronous programming. It simplifies how we handle operations that don't happen instantly, like fetching data from a server. The code snippet shows a basic structure of an async function, denoted by the async keyword, and the await keyword, which is used to pause execution until a promise resolves. This slide compares a regular function with an async function. A regular function uses the then method to handle the response from a fetch operation and return a value. On the other hand, an async function uses the await keyword to pause execution until the promise returned from the fetch is resolved, allowing the code to look and behave more like synchronous code, simplifying asynchronous operations. This slide explains how async functions work using a flowchart. When an async function is called, it checks if the operation involves a promise. If it does, the function's execution pauses, and it waits for the promise to resolve. Once the promise either resolves or rejects, the function resumes. If a promise is not involved, it continues execution. Finally, the result of the operation is returned. Async functions help manage asynchronous code in a more readable and manageable way. This slide demonstrates how to handle errors in async functions. In the basic error handling example, the try and catch block is used. The try block contains the async operations. If any error occurs, the catch block is executed, logging the error and rethrowing it. The advanced example uses a loop to retry the fetch operation for a maximum of 3 times. If the operation fails, it waits for a second before trying again. If it still fails after 3 times, it will throw the error. This retry logic provides a more robust solution for handling intermittent failures. This slide explores concurrent operations. In sequential execution, the fetch users, fetch posts, and fetch comments functions are executed one after the other, each waiting for the previous one to complete. This takes approximately 3,000 milliseconds. In parallel execution, the Promise.all method is used, allowing all 3 of the fetch functions to execute concurrently, reducing the overall execution time to approximately 1,000 milliseconds. Promise.all helps improve performance by running multiple asynchronous operations simultaneously. This slide discusses race conditions and timeouts. The first example demonstrates how to use Promise.race to implement a timeout. It creates a promise that rejects after 5 seconds, and if the fetchData function does not resolve before that, an error is thrown. The second example shows how to use Promise.any to fetch data from multiple mirrors. Promise.any returns the first successful result from the provided array of promises. If all the mirrors fail, then an error is thrown. This slide discusses async iteration. The first example shows how to create an async generator function. An async generator function can yield values asynchronously. In the example, the fetchPages function fetches data page by page, yielding data until there is no more data. The second example shows how to consume the async generator function. The for-await of loop iterates through the values yielded from the async generator. This pattern is useful for processing large amounts of data incrementally. This slide covers best practices for using async and await. On the left, some common mistakes are mentioned. For example, awaiting inside loops and using async await unnecessarily, and also missing error handling in async functions. On the right, best practices are mentioned. For example, parallel execution using Promise.all, direct promise return, and proper error handling using try-catch blocks. This slide illustrates real-world examples of async and await. In the first example of an e-commerce shopping cart checkout, multiple asynchronous operations such as validating stock, processing payment, and creating order are handled sequentially with async and await. In the second example of a social app feed loading, multiple asynchronous operations, such as fetching user posts, profile, and friends list are handled concurrently with Promise.all. After that, friend activities are loaded asynchronously based on the list of friends. These examples demonstrate how async and await can be used to manage complex asynchronous workflows. This slide summarizes the key takeaways of async await. Firstly, the core concept is that async and await provide a way to handle asynchronous operations, making the code cleaner. Async functions always return a promise, and await can be used inside an async function. Secondly, concerning performance, use Promise.all for concurrent operations and avoid sequential awaits. Thirdly, when considering error handling, always use try-catch blocks and retry mechanisms when necessary. Lastly, when considering the best practices, keep the async functions small and focused, handle the edge cases, and use meaningful variable names. Overall, async and await helps improve code readability and manage asynchronous operations effectively. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.